it's a no power. As usual, the first thing we want to do is before we connect our charger, take out the back cover. Most of the screws at the back are missing. Okay. From the JTAG, we can tell that this is a MacBook 2015-2017. We have a missing screw here. The JTAG is out, which obviously tells us that it has been for previous liquid damage no repair before, which is the reason why they would have taken out the JTAG. The Wi-Fi cable was not properly put in place, and as you can see this here, this is very bad, because what will happen is the screwdriver can then go through the back cover and then will break the Wi-Fi antenna cable. Okay. First thing we want to do, since we do not see any form of any signs of liquid damage, active liquid damage on the board, now we will connect our charger. Let's see what we have on our charger connected. We don't have charger communication, so now let's see if we have power on our board. We can confirm that. Let's open up our board view. This is an 80-00165 board. That's because it's a 2015-2017. In our previous repair, we actually worked on 2017 MacBook Airport, so we can use the same board view that's already open. Now let's check if you have a PP3B42 present. PP3B42 present will tell us that we do have power on the board, because if we don't have power on the board, PP3B42 will not be present. So let's see if we have PP3B42. 0 volt. Okay. Now do we have PPDC in? Let's remove our Wi-Fi the I/O board cable. Can measure for PPDC in here at the DC in connector. So first and second pin. Okay, we have PPDC in, but we do not have PP3B42. Now PP3B42 is completely zero. So next thing we want to do is okay, let's see if let's disconnect the battery and then try again. Let's see if we have PPDC in. PPDC in is 16 points. That is the voltage from the charger present. PP3B42 0 volt. Now let's see PP3B42 0 volt. Let's see if we have voltage at the diode for PP3B42 input, which is R. Let's check what we have on our RS705. 0 volt. So we're not even getting voltage at the PPDC in. It's not coming through to R705. So let's take a step back. Okay, now let us take the board out, and then we work our way to how we say to that we have PPDC in on our DC jack. We have PPDC in at the beginning of the circuit, but that's about it. We do not have PP3B42, and the resistor for input voltage for PP3B42 input is also not, the voltage is also not present there. So let's take out our board and get an idea of exactly what is happening. Let's stick out the board. See, the screws are halfway. It looks like somebody was trying to take out the screws before now. Wrong screws. This is on supposed to be for the fan. We used it for the board. The one for the board is for the fan. Okay, that is out. Get an idea of what's happening here. Okay, so this is the 2015 board, and yeah, there's corrosion in this section of the board here, and there's also signs of corrosion in this section of the board. Right now, we're not really worried about this section nor this section. Right now, we want to get to see how to how to get power, the primary power rail active on the board. So let's start again. Now let's open up the schematic, and then at the schematic we want to go to J7000. It's J7000. Okay, this is J7000. This is where power, this is where it says MLB2 LIO power cable connector. So this is where charger gets connected onto the device. Now we want to work our way. We checked R705, which is the input voltage for our PP3V42. However, that is not present. So what you want to do is you want to take a back trace to find out why that is the case. Now, power that goes to R705 will come from Q710. Q7010. So let us work our way to it. Let's see what do we have on our Q70. Let's see what we have on our Q7010. Let's just connect our charger again. And let's confirm that indeed we have power at some point of the board and other points of the board we don't. So let's try again. See. So yes, we do have power on our PPDCA, which is just at the DC jack. Now PP3V42 is not present. That is because we don't have power going into PP3V42 at all. Now let's see what we have on Q710. Let's see what Q710 is going to tell us. Q7010. Okay, this is Q7010. It's Q7010 is gonna be this is our Q7010 here. Now Q7010. So let's go over the pins of Q7010. So pin let's check pin 5 and 6. Let's see what we have on our pin 5 and 6. So obviously the input voltage of Q7010 is going to be at pin 5 and 6. So let's see if our pin 5 and 6 is present. We can measure that on our capacitor here, this one, which is this cap here, say 7012. We can measure PPDC in voltage. The same voltage that we have here is the same voltage that we're expected to have here. Let's see. And that is present. Just see that again. Okay, that is present. Now if that is present, the next thing we want to check it. Let's see what we have on our output. So the way this is going to work, you see that so we will have, okay, S is going to be the source, G, that is going to be the gate, and then D is going to be the drain. So Voltage, we have voltage in, which is basically PPDC in is coming into it, which is the source, and this is going to be the gate. So the gate is obviously going to determine if this is going to open or not. So and then if it opens, then you will get PPDC in out. But if it is closed, then obviously PPDC in is going to be trapped inside Q7010. Now this is a Zener diode. So basically, um, um, this is where the gate is gonna open for this MOSFET, and if it doesn't open, we will not have output on our PPDC. PPDC in output will not go to R705. Now let's see what we have. Now we confirm that we have source. Let's see what we have on our gate. Let's see what we have on our gate since we already have our source. Okay, this is this and this are going to be the input. Now let's see what we have on our first thing. Let's see what we have on pin 3. Uh, so pin 1, 2, 3 are going to be the same thing. Pin 4 stand out, and then pin 5 and 6 are going to be the same. So let's see what we have on our pin 4. Let's see what we have on pin 4. Hmm. So pin 4, we're having 16.34. Okay, that's not supposed to be. That is not supposed to be. So let's just see what we have on our output. And then the output, it's okay. Output is 0 volt, and then the reason why output is 0 volt is because it's not opening. That is why our output is 0 volt. Now the next thing we want to do is let's look at the gate. So the gate, let's see if this is present at this diode. So D7012, D7012 is going to be where's D7012? D7012. Yeah, this is D7012. Okay. Pin 2 ground, and then pin 2. Yeah. Okay. See PPDC in, PPDC in. Okay, so let's see what we have on R7011 and R7010. Okay, that is 16.3, 16.3, and then the other side, 16.5, the other side, 16.5. Okay, I'll just go back to this. So PPDC in, okay, so let's see that R7010 and R7011. Okay, so what we want to do is we want to let's measure those, but let's switch our multimeter to diode. Let's see what we have. Diode mode. Just go back here. Okay, so we can measure at this track point here. See what we have on our diode. Diode says OL. Okay, let's get another board and see what we have on that section of the board. Okay, we're supposed to have 0, 8, 1, 10. However, on our board here, it says we are having open line here, 0. So it says OL. So what I'm trying to do is, basically I want to Instead of having to measure individual components, I am kind of grouping the components together, which is why I'm using diode mode. And then my diode measurement is showing me that from this point to this point, I want to see what's happening here. So when I measure on the board, this is the board that is not outputting PPDC in, and then it says OL. However, when I measure on this board, it shows me that we do have, it's supposed to be 0.810. So the first thing I want to do is I want to remove that diode. I want to remove that diode and then replace it with something else and then test it again. And also I want to also see if I have continuity. So another thing I can do is I also want to confirm if I have continuity between that diode and the two resistors. So I want to see if I have continuity here, here, and here. So let's remove the diode. Okay, the diode is out. Let's try a bit of okay, let's just confirm that we have continuity between. Let's confirm we have continuity between this pin and the diode. Okay, we have continuity there. Let's take out the diode from the okay. So it's best that once you take out the diode from here to just install it directly. So let's put a bit of a lead in the foot where the diode is supposed to sit. Okay, let's transfer the diode now. Okay, so um, before and then what we're also going to do is we'll also be confirming because the space between pin 1 and pin 2 of this diode are very close, and then because we did add a bit of solder before putting the diode, we will want to check to be sure that pin 1 and 2 are not joined at the after the installations, which is just to confirm that we don't have a short on that first. Let's see that. Okay, we don't have a short now. So to compare, let's now see, because on this board now initially we had the diode here and we got the reading, and then we didn't have the diode. We had the diode here, but then obviously the reading we were getting was different from this. So now what you want to do without the diode being here, let's see what we get on our diode mode. Let's measure now. So it says OL. So basically, which kind of tell which obviously is fine, which because diode is not there. Now here we had a diode, but we're getting OL the first time. So which is why we have to remove the diode to see if that will change it and then replace it. Now that is replaced, let's see what we have on that line now. Okay, so that is about it. Now we have 0.789. Now initially we were having OL on that line, so we replace the diode, and then now we have, so we just replace D7 7012, because obviously D7012 it's going to play a role in allowing the gate to basically in allowing our gate to open. Now, with the gate being closed, PDCN is going to be trapped in here. But once it's allowed, once it's allowed to open, then we can now have output on our drain. So the next thing we want to do now is we want to see if we have any difference. So like I usually would like to do, I like to make sure my fan is not connected, because I do not want to expect fan spin. I rather want my multimeter to tell me what is happening, and then I know when to connect my fan. So let's connect our charger again. Initially we didn't have voltage. Now let's go back. So initially we didn't have voltage at R705, and that is because R705 is supposed to expect voltage from the output of Q7010. So now let's see what we have afterwards. So black proven ground, red probe, PPDC in, present. Now let's go to R705. Do we have anything? Yes, now we see that Q7010 is not opening, and now we have voltage at R705. Do we have PP3V42 now? Yes, and now we have PP3V42. So our issue was the diode. Now we want to see if we have SO rail present at this inductor here. Let's see if we have our SO rail present. 5 volt to tell us that we are in SO. Now that is 5 volt. So that tells us that we are in SO. So what we want to do now is we want to connect our fan, because now I know that we are in SO, and then see if we get a fan spin. Okay, that is the fan spin. Now let's wait and see if the fan reaction. We want to see if the fan is going to go into post mode, or the machine is going to go back off. Okay, the fan just went into post mode. Now let's connect our screen to see if we get anything on the screen. This is an 11 inches screen, but for test purposes you can use it, because the most important thing you want to see it, you want to see if you have a display on your you want to see if you get display on your screen, and the 11 inches will do exactly that's exactly what the 13 inches will do in terms of testing purposes. Okay. Okay, yes, we do have Apple logo, and that's it. That is an Apple logo. So, so let's just a recap. We had PPD. So we had PPDCN coming into the board, but we didn't have PP342. Now, in order for us to have PP342, let's just go back. Now, in order for us, we have PPDC in on the board, which is the voltage that comes in from the charger, but we didn't have PP3V42, which is when we measured at L7095, there was no PP3V42. We had to take a back trace to the input voltage of PPDC in. Then this diode has two inputs, one from the battery and one from the charger. So when we checked R705 had no PPDC in. We then had to backtrace to find out why that is the case. We went to Q7010. On Q7010 has the source, the gate, and the drain. The source was present, obviously the drain was not. The drain is what feeds, the drain feeds R705. So what we had to do was we had to check the gate or we had to check the gates to find out why. And then we eventually found out that D7012 was basically not functioning because when we measure using diode mode, our diode mode measurement will picked up that our D7012 is not present in the circuit. So we removed it, we replaced it, we compared our diode mode measurement on one board and another, and then we saw a huge difference between one and the other. So we removed D7012 and then we basically replaced it, and that was how that was how we got Q7010 to open. Now, when Q7010 opens, now we now have voltage on our on R705. With voltage on R705, voltage will go through D705, and then we have voltage on our PPDC, our PPV underscore G38, which is the voltage that goes into U7090 to create PP3V42. Now, with that resolved, basically the power on our board was basically addressed. Now, then there are other sections of the board like this here, which we are also going to address, and then here we're also going to address. Though those are not directly connected to our issue at the moment. However, just for future purposes, we will also be addressing that before the board will go into finalization as well as testings, and then the client can collect their device. That will be all, guys. Thank you, and then I'll see you guys in the next video.